Using our definition of a square root, what would be the square root of a negative number? If you think about all the examples and problems we've seen so far, we've always been taking the square root of a positive number. For instance, what is the square root of negative 4? By definition, you're trying to find a number which, when multiplied by itself or squared, would yield negative 4. Discuss with a partner, see if you can find that number. What number times itself equals negative 4? You and your partner shouldn't have been able to find an answer. A solution cannot be found. The reason that a solution can't be found is that when a positive number is multiplied by a positive number, the result is positive. And when a negative number is multiplied by a negative number, the result is also positive. And since a number multiplied by itself will either be one or the other of these two cases, the result will always be positive. So there are no real square roots of negative numbers. When asked for the square root of a negative number, the only valid answer is that there is no real square root. For instance, there are no real square roots for any of these problems. There would be no real square root for the square root of negative 16, or the square root of negative 100, or the square root of negative 4. Now you might wonder, why are we using this word real? Why isn't there just no square root? Well, in Algebra 2, you will learn numbers that are not included among the real number system and allow you to determine square roots of negative numbers. But the statement that there are no real square roots of negative numbers is both accurate and, for now, complete. We'll wait till Algebra 2 to explore that any further. This is what we're going to write for now at the time being. The other complication worth noting, and will also be addressed in Algebra 2, is that there is another inverse operation related to exponents, right? We said that the square root is an inverse operation. There are other inverse operations as well. We will be working with roots in this course, and the other inverse operation, though, is logarithms, but that's an Algebra 2 topic. That's why we've indicated that the square root, again, is an inverse operation to squaring rather than the inverse of squaring, because the other one does exist. We're just not talking about it until Algebra 2. So now let's do more examples just to see and kind of put everything together. We have find the square root of 4. We have the plus or minus square root of 25, the negative square root of 9, and the square root of negative 16. And the place to start with each of these problems is look at the sign that's on the outside of the square root. If you don't see anything like the first example, that's indicating a positive or principal square root. In the second example, we'll have both the positive and negative square root. In the third, we'll have the negative square root. And the fourth, you should note the negative is inside the square root. So see how that affects your answers. Well, the square root of 4 is just positive 2. Plus or minus the square root of 25 is plus or minus 5. It's both the positive and negative answers. Negative square root of 9 is equal to the negative 3, the negative square root. And the square root of negative 16, when that negative is inside or under the square root, our answer is that there is no real square root. There is no real square root of the square root of negative 16. Let's look at some more problems. Now we're actually solving equations. And again, it's all about the signs, whether they're outside or inside the square root. First, we have x squared equals 9. So if we were taking the square root of both sides, think about if that would be the principal or positive square root of 9, if it would be the negative square root of 9, or if it would be both plus or minus the square root of 9. And in the second problem, look at x squared equals negative 25. When we take the square root of both sides, think about whether that's the positive, negative, or plus or minus square root, or if it's even positive, because now we have a negative sign underneath the square root. The first problem, you should have noted that when you take the square root of both sides, we need plus or minus the square root of 9. We don't have enough context in the problem to know if we're talking about the positive or negative root, so we need to say both. X is equal to plus or minus 3 for that problem. And in the second problem, the second equation, as soon as we take the square root of both sides and we have the square root of negative 25, we have a negative underneath the square root, our answer becomes that there are no real square roots for that negative 25. Here we have some more, again, just putting everything together. Think about the square root of 4. What is the square root of 49? The square root of 64, the square root of 1, the square root of 0, the square root of negative 16. Go see as fast as you can what would be those square roots. They're all the positive square roots. They're all the principal square roots. And think about which one stands out from the others. So we have the square root of 4 is the square root of 2 squared is 2. The square root of 49 is the square root of 7 squared is 7. The square root of 64 is the square root of 8 squared is 8. The square root of 1 is equal to the square root of 1 squared, which is equal to 1. The square root of 0, now we haven't seen this yet, but think, 0 times 0 is still 0. 0 squared is equal to 0. So you can take the square root of 0. The square root of 0 is equal to 0. But that last problem should have stood out from the rest. The square root of negative 16 has no real square root. Again, that negative sign is inside the square root, and that's not okay. There is no real square root for that answer.